Okay, one problem. Yeah, let's take a quick peek at this. So this is one where we definitely, we want to use quadratic formulas for sure, right? There's no other options that look very easy. The quadratic formula is the easiest by far. We can't isolate x. You know, maybe we could factor that, but who even wants to try when we could just use the quadratic formula, right? And we're stuck with, I can't divide both sides by anything, so I'm stuck with the coefficient of x squared, so I don't want to complete the square, right? You may never complete the square, honestly. You might always just choose to, you know, if you can't do the two really easy things, maybe you always just go to the quadratic formula. That's okay. But here's the thing I wanted to reinforce with this. When we do the quadratic formula, there we go. The mistake that people sometimes make with this, that I've already seen, oh darn it, I am struggling here. Okay, yeah, here's the mistake that people sometimes make with this, is they forget that A has to be positive. And it honestly doesn't have to be positive, but you want it to be positive because it makes it a lot easier. Here's the mistake. If we don't make A positive, when I divide by 2A, that messes people up. When you get negative numbers on the bottom of the quadratic formula, especially when you have that plus or minus in there, makes it like 10 times as hard, right? So we don't want to do that. We always want to put it in standard form, set it equal to 0. And what should I do with this problem? A's negative, right? A is negative 6. How do I make it positive?
Distribute negative.
Distribute a negative, right? That's all I got to do. But whenever I see that negative out front like that, I know I'm going to distribute a negative, right? And then now it's no big deal. If I distribute the negative, I get positive 6x squared minus 25x plus 25 equals 0, right? And now I can just plug and check it, right? Plug this into the quadratic formula and go from there. If we do this, what do we get? So here's our quadratic formula. X equals 25 plus or minus the square root. If I'm squaring negative 25, what do I do instead? I never square a negative, I just square the positive, right? Or I risk making another dumb mistake. So I get 25 squared, which is 625, minus 4 times 6 times 25. Well, that's 24 times 25. That's pretty easy to do. That's just 125 less than 25 squared, isn't it? 25 squared is 25 times 25. This is 2425, so it's 600, right? All divided by 2 times 6 is 12.
How is this 6 if it's 125 less than 625?
It's not 125. It's 25 less. 4 times 6 is 24, right? 24 times 25 is 25 less than 25 times 25, right? Everybody gets that?
Yeah.
So I get 25 plus or minus the square root of 25 over 12 square root of 25 is what? There you go. Okay, here's an example where, because that's a perfect square, I get integers on the top of my quadratic formula, and so I don't separate the terms, right? At this point, I could just say, I don't even have to reduce that right now. I could just say, okay, leave it like that. What if it's a plus sign? If it's a plus sign, I get 25 plus 5, which combines easily. That's 30, right? 30 over 12, which is what? I can divide 6 in both those, right? There you go, 5 halves. Or if I take the minus sign, I get 25 minus 5, which is 20 over 12. And I can divide them both by 4. Right? See my point though? I don't need to split this one up. Now, if I had a square root over there, then those aren't gonna combine and I'll split it into separate fractions and reduce each one. Okay? Get the idea? And Moodle has changed a little bit and for the better. And it turns out that on all these problems, the plus or minus does work in your answers. I didn't even know that, but some student was doing it earlier and it surprised me, but it works. Okay?
So you don't have to separate?
Nope,
So
you don't need to.